Alright, so let's start back with number 11 here. Um, we have it tells us to do a u substitution, and they tell us what to use, which is fairly obvious, 2x plus 1. Um, so looking at the answer choices, they don't really want you to integrate it and evaluate it, they just want you to do the u substitution. But I want you to notice that on the answer choices that some of them have the limits changed, so not only are we going to do a u substitution, but we're also going to change the limits of integration. So let's go ahead and do this real quick. Well, remember these are in terms of x to begin with, right? So if x is equal to 0, we have 2 times 0 plus 1, so u would equal 1, that's the lower limit, and the upper limit would be 2 times 2 plus 1, which equals 5. So we're going to change the limits right away, and we'll put it over here, so we have 1 to 5. And then let's go back to this u, and let's go ahead and do our derivative of that. Of course, the derivative of 2x plus 1 is just 2 dx. So dx is equal to the du divided by 2. So it looks like we're getting some progress here. Of course, when you do a u substitution, this is going to be the denominator 1/2 can come out front. So we have 1/2, and then they're telling us to substitute this to be u, and so looks like that might be it. Alright, let's change pages here. Let's see, what number was that? That was number 11, so this takes us to 12. Let's see, did I skip one somewhere? Let's see. Hang on a second. Yeah, I did. I skipped one. Let me go back to that previous page real quick. Sorry about that. Alright. We can squeeze number 12 in over here. Let me change colors. Number 12, they're making a statement. They're saying that this is a, looks like a related rate problem, but they don't want you to solve anything. They just want you to translate it. They tell us that the volume with respect to time is changing to some value, a constant, and it's directly proportional. So directly proportional means we're going to have some constant out here, and the square root of what? The square root of the volume. So looks like this would be just the setup of it. They're not asking us to evaluate it, so that's a fairly easy problem, hopefully. Alright, this would be 13, sorry about that. Okay, number 13, they give you this funny looking graph. I did my best to draw it. You can see that it's got a funny cusp right here, so we know we cannot take the derivative right here at point A. At point B, there's a hole in the graph, and so there is a limit here, but it's not continuous because there's a function value above the graph here for B. I just put a dot up there, so it's not continuous at B. At C, it's continuous, and we can take the derivative because this is a nice smooth curve. At D, it has a limit from the left and a limit from the right, and they're not matching. So definitely this one isn't continuous, and that's obvious. And at E, it's continuous, and you can take the derivative there. So let's see what the question's asking us. So the question is asking us, where is it continuous but not differentiable? Well, we've already discussed that. So it looks like at point A, it's definitely continuous. They both have a limit. It approaches this value here, but you can't take the derivative when you have those sharp corners, like 90-degree corners or any kind of a cusp, anything like that. So let's move on to number 14. Okay, 14 is asking us to take the derivative of this. So this looks like it's going to be, looks like a product rule, right? So we're going to make this F, and we're going to make this guy right here G, and just take the product rule. So let me remind you of that again in case you let that slip. That's a fairly straightforward problem, so we'll go ahead and tackle that one. Number 15, sort of a problem that we haven't spent a whole lot of time with. Again, this is asking us, when is the function decreasing? And this will be fairly obvious after we finish our curve sketching section up. But just to review you, it's where the function is decreasing. That tells us where is that's asking us to solve for the derivative when it's less than 0. So they've given us our answer choices, and they tell us several intervals here. So let's take a look at one by one. And this one here, they're asking us to, is it decreasing between negative infinity and negative 1? So there's a ton of numbers we can choose. Let's choose one like negative 2, and let's just evaluate it. So at negative 2, if you square negative 2, you get positive 4 minus 2 over negative 2. Well, that clearly is a positive answer, right? That'd be 4 plus 1. So because that's greater than 0 or positive, we know this one is not correct. So we can eliminate this answer choice. Well, moving over to the next one, since we've already done a good job of choosing between the negative infinity and 0, we can choose negative 2 again and get positive. So eliminate that one as well. Looking at the third answer choice, between 0 and negative 1, so we're getting to a tighter and tighter interval here. Let's pick an easy number like a negative 1/2. If you square a negative 1/2, you get what? Positive 1/4, and then you're subtracting 2 over negative 1/2. Well, the negatives become positive, so you have 1/4 plus anything is going to be positive still, but let's just double check it. You flip the denominator over and make it 2 over 1, so you get that, which is clearly a positive answer. So looks like we are getting down to the last two answer choices. Okay, I think I'm going to skip this one because this is a non-calculator section, and what I want to do is I want to pick a number. I don't know what the cube root of 2 is, so I could pick one in here, a fairly safe number. I could pick, say, 5 or 10 or whatever. If I pick 10, it's 10 squared, or 100, minus 2 over 10. Clearly this is going to be a positive answer, right? So just by the process of elimination, I can hopefully surmise that this is the correct answer choice. If you wanted to plug in a number, you could try a number like a 1/10, 1 over 10, say. That's probably smaller than the cube root of 2, and you'll see that the answer is negative there. Alright, let's take a look at a couple more here. Number 16, the tangent line contains a point 1 and 7 and negative 2 and negative 2 to a function. So basically, graphically, what this would look like, you don't have time to do this on the test, but let's just double check and make sure we conceptually understand what's going on. So we have a point here, and then we have a point negative 2, negative 2, and and we have a tangent line going through there, and they're saying that what is the derivative at 1? Well, if the tangent line to that point is also on the graph, on the function itself, its derivative is going to equal the slope of the secant line here. So all we have to do is find the slope of these 2 points. So 7 minus 2 over 1 minus 2. So hopefully that'll get us an answer. And whatever this slope is, this positive some value, is going to be the derivative at this point. Alright, let's take a look at this one, number 17, and we'll stop the video there. Number 17 is asking us about concavity. They're saying, when is this graph concave down? And so, in order to evaluate concavity of something, we're going to look at its second derivative. So you have to take this derivative twice. So the first time we take the derivative, remember this is a product rule again, f and g. So we have 2 times e to the x plus 2x e to the x. Remember the derivative of e to the x is e to the x. Derivative of 2x is 2 right here. Okay, let's go ahead and now we could simplify this a little bit, factor out a 2 and an e to the x, and we would get what? 1 plus x. So it might be a little easier to take the derivative of this one. So now we're going to call this f and this portion g, and do the product rule again. So the derivative of 2 e to the x is 2 e to the x. Don't touch the function g. So we have 1 plus x. And then we're going to take the derivative of 1 plus x, which is just 1. And then, of course, 2 e to the x. Okay, so they both have a 2 e to the x in it, right? It might be helpful to factor that out. So if you factor out a 2 e to the x, you get 1 plus x plus 1. Right? So what is this value here? 2 e to the x is equal to 2 plus x. And this, of course, is the second derivative. So now the question becomes, what is, or when is this thing concave down, or when is this second derivative less than 0? Well, will 2 e to the x ever become 0, or will it ever become negative? Let's just look at e to the x. E to the x is a graph that looks like this. So if you double it, it's just going to get steeper. So of course that'll never be negative. So all we really need to look at is this 2 plus x. So when does this become less than 0? Well, if x plus 2 is equal to 0, x equals a negative 2 makes it equal 0. So when x is smaller than a negative 2, this second derivative will be concave down. So hopefully that helps you out a little bit. And we'll come back and take a look at the next few problems.